Moving on to the question number 6, it is to factor binomials that are differences of squares. Again, a similar problem factoring. There are various methods to solve this problem. Let's look into the problems now. Here, the first one, as you can see, it's directly a quadratic. What you can do is you can use the differences of squares formula, that is a square minus b square, that is equal to a plus b, a minus b. Now, what if you have like a power 4 minus b power 4, like this? Look carefully, I can write this a power 4 as a squared the whole square minus b squared the whole square. And now I can apply the formula. Imagine this a square, I consider u to be a square and u and v to be b square. Then this is like u square minus v square. U and v square, isn't it? Why? Because I have considered u to be a square. Whatever is inside the bracket is u, and there was above a square, and then I can use u plus v, u minus v. And what happens here? Actually, u is not u, it is a square. I had assumed it, right? So here basically you can do a square the whole square, right? So it would be a square plus b square and a square minus b square. Now this cannot be solved. Whenever there is plus here, there is no formula for sum of squares. No, there is no formula. This is it. You can't simplify this further or factor it out. This side remains the same. Okay, but what happens over here to the right side? This can be applied again, the formula. It will be a plus b, a minus b. So whenever you have a power 4 minus b power 4, it will turn out to be a square plus b square, and then it's a square minus b square, which it can be factored out to a plus b, a minus b. This would be the formula. So if you know this, and now any form, you can just get it in terms of square, and then you can simplify. What I mean is, say, imagine you have a power 6 minus b power 6. You can write this in terms of a to the power 3 the whole square. This is a power 6 minus b power 3 the whole square. And the answer would be a cube plus b cube and a cube minus b cube. Now you can't simplify this further because it's cube, so we leave it over there. So this is the thing. If you understand these formulas, then you can easily apply these formulas. Now the first part here, 121 is a perfect square. It's 11, right? 11 square, right? So you can write it as like this: x square minus 11 square, x plus 11, x minus 11. Or if you use the calculator, I'll show you now. You can press mod phi 3 and you can see here 1 before x square is 1. Then there is no x term, there's no q term, q squared, then directly number. So q term is 0. Lastly, we have minus 121. The answer is q or x equals 11. And then what's the next answer? It is, sorry for that. Here you can, okay, it got hanged. Anyways, now I'll just go to mod phi 3 and let me type this out again. 1, 0 and minus 121. The answer was x is 11 and minus 11. Obviously you could have figured it out from here, but anyways, even the calculator shows the same. So it's q equals negative 11. Now how do you write the factors? Bring this inside. It will be q minus 11 as one factor and q plus 11 as another factor. So that's the answers. You can write the factors anyway, first, second, doesn't matter. So this is the thing. Over here we have done this a while ago. I told you it will be a square plus b square. This can't be simplified further, but there will be a plus b, a minus b. But here instead of a we have r, k we have over here. Now this is the thing. What next? Another way is, we have done the way, right, of assuming values. We can do that. So I was, in the class today, I was just revising this, and one of the students told, why do we go to 1.52 is fine, right? It's very easy. Yes, absolutely. 2 is much easier. I'll just tell why I was assuming 1.5, because I used to do that from before. It's just like a habit, it's nothing wrong. You can assume even one, but I would tell you to, I'll advise you to not use one, because there are very, very rare cases, not in this, but in some cases, you'll find one won't be appropriate. Maybe when in differentiation and stuff, but you can just take it as two. It's fine, or three. You will get the same answer. And we did in the class as well with others, and we got the same answer. So no problem. You can take the whole numbers, which is easy to type out. But I was telling, since you're using calculator, it doesn't matter which number you take, it's the same thing, right? So that's why. Anyways, so we will do this in the calculator and check. I will assume it to be 2 over here. Okay, now there are two values over here. You can't assume just one value. I'll take, let me just clear it all. Let me write it over here. R to be as 2 and K to be 3. Over here, I'll take Q as 2. Let me try both the problems quickly. Q is 2 square minus 121. What's the answer? It's negative. Over here, the answer is negative 117. Now, what about the other answers? Over here, it will be 2 to the power 4 minus K is 3 to the power 4. And the answer is negative 65. So this is from the question. Now you need to find all the four options and solve it up. Use the same assumed value. For Q, I use 2, so I have to put 2 over here. Let me try 2 plus 11 multiplied with 2 minus 11. What's the answer? It matches, so it's correct. This is the correct. All the others will not match. Only one correct answer will match with the question. So this is the correct answer. Now what about this one over here? We have to use 2 square plus 3 square, close the bracket, and 2 plus 3, 5, and minus 1, 2 minus 3. Close the bracket. The answer is negative 65, which is correct. So anytime you can use this method. Now this is all the same problems. You can see the answers. Each detailed steps are there. Please refer it. Over here, 9 becomes 3t the whole square. This is, if you're wondering how you can write it, it's fine. Just use the square root of this. You'll get 25. The answer in the calculator. If you put square root 625, you'll get 25. So you write 25 square, and then again, 25 can be written as 5 square, and so on. Even over here, it's very straightforward problems. I hope it's clear. These are all self-explanatory. Even over here, this is very easy. Now, what about this one? Now, what I would suggest is use your calculators. We will go more 5, and option number 4, it's cubic, right? So substitute all the values. 3, 2, minus 147, and lastly we have minus 98. What are the answers? 7, negative. Okay, now this is a bit of a problem. Why? Because what is negative 0.66666 going on to be? It's like 0.6 indefinitely, right? Can you think of a value? Minus doesn't matter. This one, if you know 1/3 is 33% or 0.333, 2/3 is 0.666. If you remember this, then it's very easy. For some problems, only for some problems, over here we must remember that because it's keep on repeating, and then we have minus 7. So I'll write the values. We got over here it's C, so I'll take C equals, first was 7, next I'll write minus 7, and lastly we had 2/3, that is 0.666. So here the first factor would be C minus 7, C plus 7. And what about this? Take the 3 to the other side, it will be 3C equals 2, and take the 2 to the other side. Sorry, it was it plus or minus? One second. It was minus, okay? Negative, because I told negative doesn't matter. The 2 by 3 for that. But this over here, it matters a lot. Now take this inside, it will be 3C plus 2. So this is the factor. Let's check. Yes, this is the correct answers. So this is how you can easily solve it up. Otherwise, you can assume a value for C, say 2, substitute, and you can solve it. You'll get the answer. Even over here, you can try this by calculator or by direct substitution. You will get the answers. These are the steps. But I would prefer this mod phi 4. Mod phi 3 is for quadratic, 4 is for cubic. Next over here also it's the same things. Very straightforward problems. You can try them by yourselves. Now, even over here, you can try any method. Shortcut by assuming a value and checking all the 4 options, mod 5 4, or the solving method. Now over here, if you recall, this is what factoring. You're factoring the terms and then simplifying and then coming over here. We have done the same problems in the previous questions as well. Same type of problem. Now we have real world problems. Okay. So let's read this. A ticketing company for sporting events analyzes the ticket purchasing patterns. The expression 9a squared minus 4b squared is developed to help officials calculate the likely number of people who will buy tickets for a certain sporting event. We are just factor this expression. Okay, there's nothing interesting in this. They are just told factor it out. So how would you do it? We have the given question 9a squared minus 4b squared. Over here, you can write this as 3a squared. 9 is a perfect square minus 2b squared. So use the formula a squared minus b squared equals a plus b, a minus b. This is difference of squares. Now here, all you need to do is write 3a plus 2b, 3a minus 2b. This is it. That is the factored form. There you go. That's it. Very, very simple answer. That's what we got as well. Now here there's another real world problem. A bingo card contains 25 square spaces arranged into larger square. 24 of the squares are labeled with numbers and the center square is labeled as a free space. Okay. The expression 16 minus x squared represents the total area of the squares labeled with numbers. Factor the expression. Again, it's the same thing, just factoring this out, okay? Nothing much. I thought it's going to be something interesting, but they're just, this expression is the area of this particular thing. You have to just square it. I mean, simplify it, factor it. 4 squared, x squared. Use the formula a squared minus b squared. That's the difference of squares and solve it up. Last one over here. Marvin saw a rug in a store that he would like to purchase. It has an area represented by the expression shown on the rug. Over here, this one. He cannot remember the length and the width, but he remembers the length and the width were same. Okay. Factor the expression to represent the area of the rug. What are the factors of expression? Okay. Factors expression represented. Here, basically, first you need to factor this out. You can do it manually, the big method, or you can just directly put in the calculator and find it. And now, since they have told the length and width are the same, see, they have told it's the same. I'll just show you. Use the calculator. Now, if you go to mod 5 and 3, we will solve this expression. This is a perfect square trinomial because the length and width are same. That means the factors must be equal. Look, it's only x. So what does this mean? This means it is x minus 8 the whole square. Why? Because x equals 8. Take it inside, x minus 8. This is the factor, but you need to square it. There's only one x, no x1, x2. Both are same. That's the reason, okay? So now what you basically do is write it as x minus 8, x minus 8. These are the factors. And what do the factors represent? This represents the length and the width. That's it. The factors would be representing the length and the width because this is the area. So now you're simplifying. When you multiply the length and the width, you get the area, right? So basically, this is the area. And this is equal to x minus 8, x minus 8. That is length, width. That's it. Area equals length times width. That is what is mentioned here. And yeah, the expression represents the length and width of the rug. And that's it. That's the end of that particular question. That was question number 6. Very simple, very straightforward. Please do try to practice more problems and just try to remember the formula anyways, because if it is there in the last part, the part B, I'm not sure if it is there, then you need to do it in writing. So it's important you try by this actual method as well. I mean, learn the calculator method, learn the shortcut method, but try to know this exact methods as well, which will really help you. It's not that difficult, the formulas are easy. Try to remember them. That's it for this question. I'll see you in the next topic.